All right, welcome everyone to the 2026 Hoops product update. We are excited to have you here today and to be able to share a number of things that we've both accomplished last year and then also where we are headed this year with the Hoops product line. There's a lot to get through. We're going to focus on all of the Hoops products this year, so both our CAD as well as our CAE tools. We're going to start with talking about CAD data access with Hoops Exchange. We're going to go into our new Hoops AI toolkit and finish with Hoops Visualize for our CAD tools. And then later on in this session, we'll be talking about our Hoops CAE tools for data access, meshing, solving, and visualizing our CAE tools, our CAE data. A couple things. People always ask, is this going to be recorded? Yes, it is recorded. We'll share that recording at the end of this session. And then also we want this to be interactive. So this is for you. And so we're not just trying to share information with you, but we'd also like to field as many questions as possible and help you actually guide some of the work we'll be doing later this year and into next year. So please, if you have questions, add them into the question and answer panel. And then as we finish each of these topics, we'll have a few minutes just to answer questions on that one toolkit. And then at the end, we'll also have some time for Q&A. But as they come up, just add those questions to the Q&A panel, and we'd be happy to answer them. But before we get into really some of the stuff that we've done last year. There's many people here who might not be familiar with TechSoft 3D, and so we provide 3D engineering software development toolkits for CAD, PLM, CAE, 3D printing, shipbuilding, building and construction, really anything that is 3D that's not video games or entertainment or medical, and even some of those actually we play in those spaces, but really 3D engineering data, we're providing the foundational frameworks for people to build applications. And now over, I think 700 different software products are using our tools. Also, we have a growing part of TechSoft 3D that is a set of end user tools for visualizing data at an enterprise scale. And we'd love to talk to you about that. That product update is next week. So if you're here for that, we'll see you in a week. And you can register if you're interested in that on our website for that product update of our end user already built tools for the enterprise and 3D engineering data. A couple wins, though. It's been an exciting year to see what you do with these tools. We're really excited to fuel innovation with what we have under the hood of your products, to see people on the shop floor being able to get access to rich 3D data instead of going to a printer, printing out still 2D drawings and then trying to figure out what to do with those. So being able to see actually enterprises be able to utilize 3D data on the shop floor has been really exciting. To see how people can simulate the cooling of plastic and injection molding is also really exciting, and also build the next generation of manufacturing as a service tools that consume 3D parts, auto quote them, and actually begin the manufacturing process, are just a few of the areas where we see our tools being deployed out in industry, and just really excited to see some of the new software that's coming on the market. But a couple of wins here internally. A lot of times people ask, what do you do at TechSoft, and how do you use your resources? And one of the things that's really important to us is to make sure that our tools are up to date, stable, and performant. And so as we look at our engineering resources, almost 100 engineers here at TechSoft 3D, we spend a ton of time making sure that your file formats are up to date, or we're supporting the latest graphics architectures. And yes, we're not immune to bugs either, and making sure that all of those bugs, those corner cases of data and graphics are taken care of as well. Engineering efficiency is something we've really invested in a lot over the last couple of years. If you've been a partner of TechSoft 3D for several years, you might remember that we had some time ago 3 major releases a year. But now really we've been focusing on continuous development and integration and deployment. which has allowed us last year to deliver 9 different releases of our toolkits, making sure that we're able to be very responsive and continue to improve those automation tools as well, making sure we have full coverage across our platform when it comes to QA. And then lastly, we need to invest in building in the future. So we'll be talking about that new product, Hoops AI, and as well other new improvements of our products this year as well. But that focus on efficiency and quality really has been seen. So as we look at last year, even though we've signed every year about 50 new products using our software toolkits, so our portfolio of companies using TechSoft technology is growing, we actually saw a decrease in our bugs reported in 2025 by 7% year over year. So that quality is improving, even though we have a much larger audience of people using our tools. Well, at the same time, we're able to increase our ability to resolve those issues. And that has been a real focus here. We all know when you send out a request into a support portal, how it feels if it just goes into the abyss. And so making sure that we're responsive and are able to resolve those problems as quickly as possible. That's decreased over 30% in the last 2 years. So just a couple things happening here at TechSoft. Let's talk about our technology now. I'd like to introduce Marco. He's going to be talking about Hoops Exchange, where we've been and where we're going.
So thank you, Jonathan. Let me introduce briefly Hoops Exchange for those of you that might not know it yet. So Exchange is our solution for CAD data access. Sorry, Jonathan, still on the intro slide. The data access is at the core of Exchange. It's not just simple file translation, as a very important point to consider. With Exchange, you can access data from over 30 CAD formats performantly and without any dependency on these CAD formats. We can access BREPs, tessellation, metadata, PMI, and you can transfer the data you need into your own structures with very high fidelity. Of course, you can also use Exchange for file translations, as we can export to over a dozen formats. It's also worth mentioning that Exchange can perform, geometry adaptation, point projections, clash detections on imported data. So it also allows for more advanced operations. So let's review what the Exchange team accomplished in 2025. We can start with our partner requests. As always, we do our best to satisfy as many requests as we can. We always try to add as much value to as many of you in our product. So in these slides, I have a few examples of what we introduced throughout last year. In early December, we extended support of the ISO 14405 GD&T symbols in CATIA v5. This was an important capability to support some of our partners. It needed to be done in a timely fashion, and I can say that we did so. Also, we are going to deliver the same extended set of symbols for NX later on this year. We've done some work also for the Clio file format. We could already support layers at part level, and we now can also read layers at the assembly level. We also introduced support for family tables accelerator files. So what are these? So accelerator files contain pre-processed family tables data so that an application can skip a lot of the generation of this data. Using these files, you can reduce dramatically the time needed to open instances, assemblies, and also you reduce the time spent in the regeneration of this data. Still in Clio, we can now support simplified representations, which are, what are they? But they're another powerful feature to make it easier to work with large data. With simplified reps, as they are usually called, you can load, resolve, and display only the data that you need. You can exclude or suppress what is not necessary at the moment. We also did some work in GLTF, in the GLTF reader. We added support for Draco compression files, and we also improved the handling of wireframes. In Revit, we introduced support for connector points and a better management of the metadata. This is especially applicable when processing duplicates and when filtering and files with lots of empty properties. And finally, for 3D XML files, we can now also import markup linked items. To conclude this slide, we have an extended number of supported platforms now. There's two new entries that you can probably see from the little icon here, iOS and Mac Catalyst, which now have full parity with macOS in terms of natively supported readers and writers. So next slide, please, Jonathan. Thank you. So in 2025, we also worked on larger projects or initiatives. Early last year, we released an experimental USD writer in collaboration with NVIDIA. You might have heard this or noticed it in our releases. So why did we do that? Well, we have been seeing a growing adoption of USD in the engineering space where we operate, and several partners working in manufacturing, digital factories, digital twins, to name a few verticals. They requested us to connect to Omniverse. Omniverse offered a lot of advanced capabilities for simulation, real-time photorealistic visualization, AI inference, and many more. And they wanted to have an easier path to bring the data into this platform. So yes, we released an experimental USD writer, but we also joined the OpenUSD Alliance so that we could stay closer to the development of this format. The writer has been in experimental status for quite a while, and we'll see why in a slide or two. We have also continued to work on DGN. We released our DGN reader as general access last week with the 2026.1.0 release. For those that who don't know what DGN is, it is Bentley Systems proprietary file format. It's used in MicroStation and all the open application built on top of it. It is one of the most capable and widely used file formats in AC, especially when dealing with massive infrastructure projects. That's where you'll see it used extensively and where it can really flex its muscles. So our reader can import both the legacy V7 and the current V8 version of the DGN, supports the most commonly used data types of the format. So if you use your DGN or you think you have a chance to use a DGN in your applications, we'll be very happy to hear your feedback so that we can keep improving support for this format. Another major project that we worked on last year is what we call the computational tessellation. You might have seen this in last year or in other presentations. To give a bit of context, so Exchange can generate two types of tessellation when importing data, standard and accurate. Standard tessellation is the most widely used. It works great for fast conversions, general purposes like visualization or manipulation of parts. On the other hand, the accurate tessellation is meant for those use cases where you need more precision and accuracy, as the name suggests itself. For example, simulation, additive manufacturing, but also today's high-end visualization platform need a high-quality mesh to take the best out of the 3D data. So throughout the years, we had several requests for improving our accurate tessellation. So we decided that it was a good project a good challenge, to be honest, for us to embark. So last year we started the project. We did a lot of homework. We did a lot of benchmarking, baselining on what we already have, and we evaluated a number of possible solutions for improving our accurate tessellation. In the end, we decided to implement something new that will guarantee much better results when you need higher degrees of accuracy. So next slide. Yeah, thank you. So let's now go through what we currently plan for 2026. And we can do so by continuing to talk about the new tessellation project. So as I mentioned before, we decided to implement a new algorithm. This algorithm is based on quad tree meshing, and it will replace the current accurate tessellation. Now, don't be concerned. The accurate tessellation, will stay for a while, at least until we can guarantee better results, and it will give you ample time to move on. So this project is massive, it's complex. We'll continue to work throughout this year too, because it's very important for us. Our main goal currently is to be able to generate a tessellation that is watertight and manifold. We have been making very good progress on this. We released a first experimental version of the API last week with 2026.1.0, but we already have significant improvements ready for our next releases. But we all know the meshing is a very complex business, different use cases, different data, depending on what the mesh is going to be used for, require different tuning of the algorithm, different parameters. What is an optimal result for one use case is not necessarily the same for another one. So we also know there will be a lot of corner cases that will come up as this new meshing tool is being used. So rest. Know that we plan to keep delivering incremental improvements for both mesh quality and optimization throughout a year at least. So the project will not cease with our first general access release close to this summer. If you're interested in this project and you have some data that might be specific to your own industry, to your own sector, and you want to share with us, you want to collaborate with us, it'll probably help us to validate our work in a broader variety of applications. Okay, thank you, Jonathan. Next slide. So in 2026, we're also going to work on some file formats. We can start with USD. Said before, I'll tell you why we kept our current USD writer as experimental. Well, that's because we are going to develop a new and improved USD writer. So the introduction of the experimental one last year really helped us to confirm that the adoption of USD by the 3D engineering space, it's increasing rapidly, right? It's going it's going past the original domain of computer graphics. We also believe that USD could become a key intermediate format for manufacturing, AC, digital thread, and cloud-based applications in our domains. Why? Well, these applications need to deal with a huge amount of data. They have collaboration, built at their core. They need machine-readable data for automation and AI workflows, which are becoming more and more pervasive and critical. And we think that USD can tick a lot of these boxes. USD was conceived to deal with massive models, to work with multi-asset files, where different types of data or different representation of the same data are stored in small files, which make the transfer of the data needed in a specific context very fast and efficient. For example, USB also is based on scene composition, referencing, instantiation, layering, supports overrides, and all of these capabilities make it a natural fit for non-destructive collaboration and versioning, for example, but also for a very efficient reuse of the data. And if we think of digital thread, for example, the two pillars are data referencing and avoid data duplications at all costs, and which these are two of the pillars as well of the USD format. There's also other native concepts like variants and LODs that can really help with configurations management. And also its language is very similar to JSON, which means that it is structured, machine readable, so very suitable for automation and AI. Right, so while you probably understood that we think the USD can be much more than just another interchange file format, our first goal is to release a new USD writer, fully integrated with Exchange, not a separate package like the one we have now, and that will support all of these advanced capabilities. Then the next challenge will be enriching USD with all the data that is necessary for our industries that is not part of the standard. But thankfully, USD is also designed to be extremely expansible with custom schemas. So we have good confidence that something good will come out of this. So again, if you operate in any of these areas, if you think the USD could be beneficial in your sector, or if you, like me, are simply just excited by the potential benefits of this file format, please get in touch with us. We'll be very happy to hear your thoughts and discuss on this topic. Thank you, Jonathan. Next slide, please.
Do you want to talk about QIF?
Oh, sorry, yeah, forgot. Yeah, sure. So QAF, yeah, the second format that we are talking about, we're going to work on is QAF. So we are seeing an increasing demand for reading the QAF data across several industries, for example, aerospace and defense and automotive. So QAF is an ISO standard. It looks like it's being seen as an accelerator for automation and data traceability, which are, data basically pretty much digital thread applications, which are becoming more and more important to in several sectors. So we decided to work on a QAF 3.0 reader. The scope of this will be importing CAD and MVD data, and we all plan to have it available as a beta version by the end of Q2 of this year. So same as for USD, if it's a format that could be of interest for you, if you think that you can and want to help us in its development, if we could have access to different types of data, it will really help us for test and validation, as QAF is still fast evolving and there's not a huge amount of variegated data we can work with. Okay, thank you, Jonathan. So yeah, next slide now for real. So of course, we're gonna keep trying to fulfill as many requests as we can. We can mention, the some in the file format announcement area. This year, we're gonna add support for arrangements in Siemens NX. So what are arrangements? They are a powerful way to manage multiple configuration of the same assembly. You can do so by changing component position, suppression states, visibility, without having to duplicate and regenerate the models all the time. So without arrangements, you would have to use different copies of the same data to represent different configurations. While using arrangements, the information of these configs is stored in the file, and you can switch instantly between different configurations, and also you avoid duplication of data. The scope of this will include the suppression of components and transformation at the assembly or subassembly level. That's something we still have to define. We're also going to add support for inseparable assemblies in Creo. Inseparable assemblies are assemblies that behave like a single unit, like a single part when in a higher level assembly. So instead of exposing their internal components, they are treated as a single unified object. So they are used mainly for improving performance, stability, but also for data protection, especially in complex design, because basically the internals of these inseparable assemblies are hidden, they're not selectable, and the whole model, it behaves like a sealed black box. Now, talking about request, performance is always at the top of the list, or at least it's always on the podium. Things could always be faster. We all know that. So this year, what we intend to do is to introduce multiprocessing to the import of assemblies for CATIA V5 and NX formats. So this project is not trivial and needs to be done for each individual reader, and this is why we'll start with these two formats, which we identified as the top priorities for now. So after we introduce multiprocessing for these two formats, we'll investigate if this can also deliver value to other formats. We need to do some research. Not all formats are probably going to benefit in the same way with this capability, and we really want to invest where we know we can deliver significant value and improvements for as many of you as we can. Okay, thank you, Jonathan. So, well, here there is a very, this is a snapshot of our current plans for 2026. all the features I talked about are in here. There's a couple of extra ones like the sweep feature for Creo that we're gonna work on in Q2. There's also the systematic bill of materials generation, which it's a kind of a cross-product effort as well. And of course, last but not least, really here is the timeline for our format updates. So they didn't have a slide on their own, but rest assured they stay at the core of our efforts. We'll do all we can to keep delivering updates in a timely fashion. So I think with this, I'm going to leave the stage to Eric, that's going to talk about our approach to AI.
Yeah, before we do that, we have a quick poll. We are curious about a couple formats. So we have an opportunity. We launched a poll here, and then we do have a minute for any questions you may have. I don't see any here in the Q&A panel, which is fine. There'll be an opportunity at the end, and then if you quite possibly you see a format on there that you want to support, it's not on this poll that you may want to support. At the end of this webinar, we'll have an email that goes out and it allows you to submit other requests as well. And of course, you can do that within our support portal at any point. But it looks like we have some interest in USD imports and some interest in Windows ARM. So there's not a whole lot of Windows ARM devices out there yet, but it looks like several are coming on the market later this year. And so that is something we are interested in. And so thank you for submitting those poll answers. I'm gonna end that, and I'll share those results. And then yes, we would like to welcome Eric to the stage to talk about our newest product in our portfolio, Hoops AI.
Sorry, Jonathan, there's a question, if you don't mind, just before we start in the chat here.
There is, yeah.
Very quickly. So for Jad, so he's asking why, there's sometimes, there could be issues in, writing GLTF files when there are wireframes. So as I said before, so this year we worked on improving the reading of wireframe. On the timeline, there was a bar that is for GLTF improvements. That is mainly the working on the export of wireframes and the support of Draco compression on export. Now we gonna have some cases where there's some bugs. So best thing to do is to log them in our support system. We'll deal with them as when we got more details.
Great. And there's another question in there about PMI to STEP AP242 support.
Yeah, so that I'm not sure if it is part of. We're gonna do some work on STEP AP242, and it's mainly quality. It is definitely something that we can start to evaluate. I'm not sure if something we could do this year, but yeah, absolutely. Make sure again, if there is a request logged, please, it will help us to gauge interest and give it the weight. Okay.
Yeah, great. Thank you. And thanks for your questions. If you could, instead of putting them in the chat, put them in the Q&A panel, if that's possible. We're flexible, but that helps us out. Thanks so much. And over to you, Eric.
Thank you. Thank you very much, Jonathan. You can directly move to the next slide. So yeah, thank you. Well, of course, it's a particular moment in a career to launch a new product. We don't do that every year. Yeah, we are all super excited at TechSoft by the potential that Hoops AI we believe we'll have in our industry. We've launched a beta release in November, mid-November. We already have 20 people who've tried it. We get a lot of excitement, a lot of feedback. So super exciting moment for us. Before I deep dive into the capability of Hoops AI, I like to take a moment to share the visions we have and the problems we'd like to solve. So you can move to the next slide, Jonathan. Ready to start from an high level, we do believe that there's a lot of knowledge that is implicitly attached to 3D CAD file format. And today, most of this knowledge is not leveraged by the tool and by the process we are using. When you just like, sorry, I lost my voice, but when you just look at a part like the one that there is on the screen, if an engineer who is working in a manufacturing company for 20 years, look at that, there is many things that this engineer will understand instantly. He will understand probably what's the cost of this part. He will understand some sourcing informations, what manufacturing process to add, if a tolerance here or there matter. And the reality is that most of these informations are in his head. Some of that are sometime in our information system, in our PDM, in our PLM, in manufacturing execution system, but most of that is kind of lost in translation. The beauty is that we really believe that there is an opportunity for the software that you're building to capture that. What people are doing with your software is that they interact with this CAD model, they use tools that you're providing, and we believe that we have the opportunity to capture this knowledge and to correlate that to this 3D model to basically drive automations, to provide direct business value from this knowledge. If you could click to time, Jonathan. Thank you. So, of course, if we want to make that happening, AI is going to be really useful, to capture all this knowledge. But the reality is that today, everything is to build, from scratch, because many pieces are missing in the ecosystem. Actually, just to start as a foundational problems, there is no tool that exists that help people taking a CAD file and transform this data so that a machine learning model can learn from it. Even if you have that, there is basically no machine learning model that exists today in the industry that can understand 3D shape. You have some tools that exist, but they don't capture and they don't work with the type of data that we are working with, in the engineering world. So really, our objective is to, progressively build these tools so that, again, we can automatically take a CAD model like that one and correlate that to a manufacturing process, to sourcing informations, to basically capture all this knowledge and automate and provide insight from that. So moving to the next slide. So as we look really these, bigger problems, of course, we start with the, foundational problems. And so we really focus on that. The first things to resolve is to basically, take this CAD data and transform them so that a machine learning model can learn from that. A machine learning model doesn't understand CAD. It doesn't understand what an assembly tree is, what a mesh or what a BREP is. And there's a lot of work which is not easy to do that, data scientists and engineering team have to go through to do that. So we basically build a full frameworks that can take 10,000 or 1 million of CAD file, can transform that, can help you preparing this data set and encode all this information so that it can be built or so that a machine learning model can learn from it. You can see that there's many modules as part of this framework, CAD access, dataset prep, encode, and so on and so on. I'm just gonna cover quickly some of them to give you more insight on what they do. So moving to the next slide, Jonathan. So CAD access is something really simple. When you work with machine learning model, you work with Python. So we've built basically a Python wrapper on top of OpsExchange. With that, with a couple of lines, basically, you can extract an assembly tree, you can extract your BREP informations, you can display that in a Jupyter notebook just with few lines. So that makes things much more simpler and that enable people who work with machine learning to basically work with Python, with PyTorch, with the tech stack that they're used to work with. Moving to the next slide. The next step, I mentioned that quickly, is to transform a CAD model into something that a machine learning model can understand. So a machine learning model doesn't understand topology, geometry, assembly tree. There's a lot of work that we do to basically transform this information at scale. And that's what this module, Oops AI Encode, take care about. Not only we encode that, but we provide many tools so that engineers and data scientists can interpret their results, can understand what's happening, and at scale. One important thing also to consider is, working with one CAD file is different than working with 10,000 CAD file or 1 million CAD file, which you have to do basically to train a machine learning model. Next slide. We also deliver tools to basically help engineer to build data pipeline at scale. So transforming data for machine learning is really about going through different steps that transform your data incrementally. We do all of that in parallel. We store everything which is done across this pipeline so that people can debug, can try different experiments, and can version this different experiment. So that's what Oops AI Flow is doing. We also deliver some machine learning architecture as part of this framework. So it's not just the tooling, it's also sample that you can leverage and tune. So we've delivered two specific samples so far, one that take part and classify them, and another one that can recognize manufacturing feature. So the quality, of course, depends on the data you're using to train this model and depend on the use case. But any, software engineers and data scientists who, start from scratch will save many months of work if you're interested in solving this problem by looking at your sample, by using our frameworks. So hopefully this gives you, a kind of quick overview on what we're trying to achieve, the big visions we have and what we've delivered so far. I'm just going to give you a quick overview on what we plan to work on in 2026. So again, we've delivered a framework so far to help you transforming your data. There is more work to do with these frameworks. We'll deliver Linux versions within a month. We'll add additional tutorial and we'll launch this official release of Oops AI, basically, in the worst case, March 30 and probably earlier. Another important element of this framework is to make sure that you have access to any type of information that Oops Exchange provide with Python. We just cover a subset of that today. And so we're planning to enrich that. One of the most important type of data, for instance, that we want to load our PMI informations. We do believe that machine learning can help a lot with that, the assembly tree and much more over time. We also, moving to the next slide, Jonathan. So that's kind of, one track. You remember our visions, all these building block that we need to have basically to, leverage and correlate business informations, business process to a CAD file. So we're not just going to start, at this framework level. We've already started also to build additional component, additional machine learning architecture to start to build machine learning model who understands what the shape is and what a part is, but also what a feature is. So we call that Oops Embedding. We're really focusing on machine learning model that can take a shape, a part, and understand it. And we're also interested at the exact same problem at the feature level. Having machine learning model that can understand what a null is, but not just locally, in the context of the global shape. If you think about the type of things we try to do in our industry, we try to automate the generation of PMI, automate manufacturing process. And so understanding that you have a null in a part is not enough. You need to understand the context of this part. Is this part a toy or is it a component which is used for aerospace? And so that's the type of model that we're trying to build. I think the next slide will make things a little bit more concrete. So what do we mean by geometry awareness? Well, the good thing is that, in fact, we already just last week deliver one technology that understands geometry at the part level. The way it works is pretty simple. You take your CAD file. They don't need to be prepared. They don't need to be labelized. And we have a non-supervised algorithms which is gonna, learn just by loading your CAD file. And this algorithm is gonna retrieve a different pattern across all your data set. It's gonna create an embedding. There's maybe a few people who are familiar with that in case you've been working with, large language model and RAG systems. And at the end, we'll have a kind of, representation of all your data set. And each part of this data set will have a particular vector, a particular signature. Once we're there, basically, we are able to, instantly recognize every single part which are similar with your data set. And if you take a new part that your system has never seen, we'll be able to retrieve the part which is the closest to that with similarity score. Moving to the next slide. So you can just see an example of these algorithms, like on the left side, we just drag and drop a part, that's the query, into the system, and immediately, basically, we recognize in the database every part that were similar. And so we do that because, again, this algorithm learn shape, it learn how to recognize pattern and shape that are similar at the part level. So just to try to loop, the full story, why is it useful and what type of generic problem does that solve? So, well, of course, finding similar parts is, useful to avoid duplications. If you are, in a big manufacturing company, you try to reuse the components you have. But more important than that, people certainly have, certain parts, certain systems that have knowledge attached to that. If you manufacture a particular part, if you know the cost of this part, for instance, well, finding similar part will help you predicting the cost of the new part that you just received. And so if you take this pattern, again, back to correlating business process informations to a 3D shape, that's the pattern that we try to retrieve. So we have a beta available for this technology, well, since last week. If you are, interested into that, please reach us. And more generally, if you're really interested in these, broader problems, if you think that there is things that could be automated in your applications, or that there is implicit knowledge attached to a 3D shape that can optimize, your manufacturing sequences, predictions, or cost predictions, or whatever process, well, that's the problem we try to solve. It's a journey, what we deliver already provide a lot of value, but yeah, we will welcome you in this journey with us. So thank you.
Great. Thank you, Eric. Yeah, there's a lot going on there and some exciting new features to it coming this year. We do have two questions. So one for you, Eric, then I think maybe one for Marco. So I'll give you hopefully an easy one for Hoops AI, Eric. What data sets are used for training, and are there pathways to do training on our own private data?
The second scenario is the one that we enable and that we anticipate. So today, what we deliver is just train with public data set, but we really believe that there's a need for people and enterprise to train with their own data. First, because these data are proprietary, but also because they are, well, more significant to the problems you're trying to solve. It's not useful to train a machine learning model with chair, table, if you're, building pump or airplane. And so, yes, we enable you to train that with your own data set or with the data set of your customer, in fact.
Yeah, good. So that's the intention really, is to use your own data. Great. And then maybe for you, Eric, but also for Marco, are there still plans to add a Python API for Hoops Exchange?
So yes, I think so basically, we're still working on that. I'm not sure it'll be this year. It'll probably be after we supported fully, the Oops AI release and development. Before we can make them public for exchange, there is further work that needs to be done to increase coverage, slightly different system to generate them. So yes, let's say they're not on the roadmap because it probably won't happen for exchange this year, but it's not something that we are definitely shelving or archiving.
Eric, do you have anything to add? Because I
Yeah,
know
no,
Hoops Exchange
yeah,
relies.
no, more or less the same. Our priority is to basically complete the Oops AI Python API with additional data that are not covered today. And we'll probably make this wrapper, this Python wrapper that we've built for Oops AI, part of Oops Exchange in 2027, once it's more complete.
Yeah, because Hoops AI relies on Hoops Exchange heavily, and there
Yeah.
is a Python interface within Hoops AI, so there is some data from Hoops Exchange you can get within Python, but it's very limited.
Yeah.
Great. Excellent. Thank you for your questions. And thank you, Eric, and thanks for suffering through. I know we've been working you hard this week with your voice, but thank you so much. Really exciting stuff there. On to Michael Young. We'll be talking about Hoops Visualize and our graphics engines.
Thanks, Jonathan. For those who are not yet familiar with the Hoops family of toolkits, I'd like to introduce you to the Hoops Visualize family of products. These are engineering-focused 3D graphics engines for web, desktop, and mobile applications. They feature easy-to-use modern APIs that enable interactive, high-performance graphics. We allow you to integrate graphics into your application in a fraction of the time is required to build your own. These tools are deployable on all contemporary platforms: Windows, Linux, Mac, Android, iOS, x86, ARM, you name it, we support it. And they're maintained by the graphics display technology professionals at TechSoft 3D. We have two products within this family, Visualize Web, and we'll start by looking a little bit backwards at what things have happened in the last year of development on what used to be called Hoops Communicator. We had a name change partway through 2025, where we're simply rebranding things to consolidate the product line to make it a little bit easier to understand. So what you used to know as Hoops Communicator, we now call Hoops Visualize Web. A large portion of last year was spent on modernizing the product. We introduced a new user interface based on open source web components. The initial release of the new UI started in version 25.2 and went through the whole year last year with continuous delivery of improvements. The UI that we're providing is ready to use for those who need a quick go-to-market solution and are happy with the standard out-of-the-box web viewer. We also, through using the web components technology and open sourcing the viewer code, provide you with a solution that is ready to be customized. You can now download the source code for the viewer at GitHub. We're also in the spirit of modernizing how the tech stack is built and delivered. Also, now we provide the binaries for Visualize Web via NPM and the TypeScript code via GitHub that will help make all of your upgrades easier. Since the introduction in November of the NPM server and the GitHub access, we're averaging 125 downloads per week. Clearly, there is interest and popularity out there for providing this channel for you to access OOPS Visualize Web. And in addition to modernizing the user interface, we're also focusing time on making the API more usable. The whole SDK is becoming more modular so that class responsibilities can be more coherent. We peeled out the material information into its own abstract class so that you don't have to do everything with the model class anymore. We do have the material interface that was introduced last year to focus on just those responsibilities, and there's more to come in 2026. Performance enhancements are always of interest to our partners as data sets only continue to rise, and expectations from our customers and from your customers for having an interactive application, those expectations also continue to rise. We spent time to improve the frame rate of the graphics engine by reducing the number of draw calls required. And on the conversion side, loading SC data from converted IFC files has been drastically improved when loading the IFC relationships. One comparison with a competitive product showed reduced loading time by 60%. Not all the action was on OOPS Visualize Web. The desktop and mobile SDK also received a bunch of investment this last year. The volume rendering capability that was previously available in the 3DF API of OOPS Visualize is now available in the HPS API. That's a lot to say quickly. There's now the cellular volume kit is in the API that enables you to display 3D volumetric entities. This came in November of 2025, and what we expect to see is the addition of selection and highlighting in this API in the first quarter of this year. A large number of things that we focused on were things that you, our partners, have requested. We added a character attribute kit that enables you to configure individual character attributes in any combination of color or size or modification. So your italics, underline, bold, you can mix and match everything on a per character basis now. We added animation ticks that can be used to implement sliders for scrubbing through frames in an animation. The addition of the string cursor that has been available in 3DF for years is now available in the HPS API. Object files, the output and the input now handles all of the transparency modes, full, diffuse, alpha, and RGBA. And we also added an edge generation options kit that allows you to set, unset, and show adjacent edges, hard edges, set the default face and edge visibility, ignore local face and edge visibilities. So you have quite a bit of flexibility in how edges are treated. Finally, we added platform support last year for Linux ARM, and also updated our support on Visual Studio. We're now up to Visual Studio 22 with the packages you can download, and also .NET 8 support. We'll talk a little bit more about that in a minute of where we're headed with the future of the Windows development tool chain. So for looking for next year for the Hoops Visualize Web project, we continue to focus on modernizing the product all around. We have strong interest from several partners to provide custom shaders that will enable you to make your own custom rendering effects and insert them directly into the rendering pipeline for the graphics engine of Visualize Web. We are going to move on adding web GPU support to allow high performance rendering of complex scenes, access to modern GPU features, parallel computing, all to help enhance interactivity of the viewer. And the third component of our modernization effort is to provide the Hoops Visualize components in containers that can be then orchestrated. This is being driven from the cloud application development market, is less focused on individual low-level software development toolkits as Visualize Web traditionally has been. We want to provide the toolkit in a form that is easy to use off the shelf. So we're moving to containerize the toolkit so it can be plugged into a cloud application with less effort on your part. We have many customers who are doing many of the same things to take the low-level SDK and get it ready for deployment. So we figure there's interest in taking some of that work off your hands and provide you something that can work off the shelf. Several partner requests that we're focusing on as well, things that are of interest to many customers that we interact with. We're currently building out being able to specify the render mode of object by the object. So if you want to mix and match transparent and hidden line and opaque and different shading modes, you can customize for each body in the scene in order to highlight things that are of interest in the view. Also looking at being able to auto-orient the PMI in your scene. We have many people who have asked for, when I change the camera view, I want the PMI to automatically flip so that it always stays readable in order to increase the usability of their end user applications. Selecting and manipulating markups, dimensions that are created in the viewer. This would make the scene more interactive and make it possible to select measurements for further interaction, moving after placement, selecting for deletion, associating to application data. And finally, performance, I think you'll see in everybody's slides today, because performance is always a critical parameter for our customers. We're looking at ways to decrease the time to screen by compressing tessellation data as it gets pushed from the server to the viewer. Lots of exciting things happening on Visualize Web. Likewise, on Visualize Desktop, our intention is to secure the investment that you've made in Hoops Visualize technologies for desktop and mobile, so that 5 years from now, 10 years from now, you still can see the value and have a rock solid technology underneath your viewing needs. We will be focusing on staying up to date on development tool chains with the new Visual Studio and .NET 10 coming available at the end of the year. We will be providing support for those. We're also increasing the minimum level of support for the GCC toolchain. So GCC 10 and above is supported. We're finally able to say goodbye to Linuxes like Red Hat 7, just in time to start saying goodbye to Red Hat 8. The biggest investment that we see in Hoops Visualize for the desktop is in the performance area. We recognize that Hoops Visualize has been around for a while, and as data sets have increased, it has stressed the graphics pipeline that is in Visualize. We are working with many partners to identify use cases where we need performance improvements and looking at how can we rebuild the graphics pipeline in a way to handle 10 times the amount of data that we're able to handle today. Again, to ensure that your investment is still maintained into the future as data sets continue to increase. And I'll just sign off with a brief look at the roadmap as it is. As Marco mentioned, we are all interested in providing software bills of material across all products, Exchange, Visualize. We have increased demands from our customers related to European Commission security standards, and we're being pushed to provide you with better quality information that can be updated instantaneously. Okay. Thanks, Jonathan.
Great. Thanks, Mike. We got a poll up there and a few minutes for some questions. We had one about what happened to Hoops Communicator. Well, nothing. It's just been rebranded as Hoops Visualize for Web. Same product, same API. No real change to upgrade except just a new name. So that should be simple. We have another question here. How much of the Visualize desktop discussion applies to 3DF? So we do have like two flavors of Hoops Visualize for desktop. 3DF that many of our partners are using, and one called HPS, which is slightly more object-oriented flavor of the same engine. So moving back, Mike, how much of that new stuff is going into 3DF as well?
Well, the rendering pipeline is core technology to both APIs, so that any improvement in the rendering pipeline will be visible in both products. And likewise, volume rendering has already been available in 3DF for a year. Qt 6 compatibility, .NET MAUI support, and Visual Studio support, these will all be maintained in both APIs.
Great. And another important question, thanks, Mike, which is kind of for the team here. So a software bill of materials, the exact timeline for us to deliver that. I know there's a lot of interest, particularly in Europe, over security and security vulnerabilities and resolution time. What is our timeline for providing that?
I can take it. Likely this year, in all case, we have one big priority to be CRR compliant under the couple of milestones that we really look at. One is September 2026. The next one is 27. So and yeah, SBOM is part of our roadmap for this year. I cannot say if it's Q2, Q3, Q4. I don't remember, but I know it's planned.
Great. So it's on the map. Thanks for the survey. Seems like DirectX 12 beat out Vulkan, and there is some interest for graphics on Windows ARM. And then one last question here about IFC 4.3. Will there be support for IFC alignment, relative position of shapes to geometry shapes, like curves, according to defined equations? So that might be more for Marco. So IFC Align, I'm not sure if we have that info at our fingertips, but it's a good question.
Yeah, so I think that when we added support for 4.3 last year, we kind of added in a bunch of classes, and I'm not sure if that is supported. To be honest, I probably have to get back to the team
All right.
and confirm if something's missing. The best way is again having log in a feature request or a contact support, and then we'll figure out if it's something that doesn't work well or that's missing.
Great. Yeah, so we'll get back to you. Thanks for that. All right. So next up, we have our CAE tools. So I'd like to introduce Andreas. He's going to take us through what we delivered last year when it comes to data access, meshing, solving, and graphics for CAE.
Yeah, thank you, Jonathan. Yeah, for those who aren't really familiar with our CA toolkits, we do the same thing as the CAD toolkits, that is data access, visualization, and on top of that, we have some specific toolkits for the simulation side, meshing and solving finite element equations. So let me run you through the 2025 output of our engineering team, starting with Hoops Envision. We had a major project in the first half of the year. VisStreamer is the name of the component in Envision. It actually opens the streaming technology of Envision to any sort of data source with a clear target, which is legacy desktop applications. The idea behind this is to really facilitate and reuse all the legacy logic of a CA desktop application and be able to stream that in a very efficient way to a browser. Another major, much smaller, but a very, very nice improvement we made on the desktop version of Envision. Forgot to mention it comes in web and desktop flavors. Is the ability for our users now to fill in cutting planes that are made on surface objects, hollow objects, which would, if not, be shown as a contour. Now it's pretty easy to fill that up and have a good idea of the interior of the objects. Next slide, please. When it comes to Hoops Mesh, Hoops Mesh is really it's a meshing toolkit, of course. I like to see it as really a toolbox of meshers. There's various meshers there, 2D, 3D, extruded meshing, and you can combine those in very efficient ways. What we worked on here is exactly in one workflow where that combination is very useful, which is conformal meshing or coincident meshing, various objects with various interfaces that need to have exactly the same mesh on those interfaces. So we did quite a lot of work to make that as developer friendly as possible. Another, within the same process, we have sort of extended the extruded meshing. Now it's really very general. It allows to extrude any section along any path in a very, very quick and efficient way. Looking at Hoops Solve 2025, we did some optimization on a very corner case, which is beam sections. We were carrying on too many properties. I'm not going to go into detail here. So basically one pretty major performance improvement in terms of memory. Our main focus here, and maybe also with Mesh, it was really to better expose the product. So we've been working on improving the developer experience for Mesh and for Solve. Here in Solve, trying to clarify and simplify our tutorials to make the product easily adoptable. Hoops Access, that's our CAE data access solution. It reads about 30 formats like Hoops Exchange does, but in the CAE space. That includes input and output file formats. And it also has the ability to write out input and output formats for about 10 different flavors. One big project we did for one of our partners here is to support cyclic symmetry data in input files, focusing on our tier 1 formats, Abaqus, ANSYS, and Nastran. On the format front, we added couple formats in the VTK ecosystem. We are now writing out results in the VTU format. And for a project that will be presented in a few slides, we started supporting VTK's polydata format, VTP, in order to be able to read particle-based output files. Most of our work is really extending our format coverage on the many formats we support. And we spent quite a lot of time this year in just doing that, adding more and more features to a very complex data sets that we have to handle with the CAE readers and writers. The final point is really, again, focusing on the developer experience. So we have worked on simplifying the C API, which, due to legacy, was quite verbose. So first step in improving that developer experience has already been released and really allows to reduce the number of lines to achieve the same goals. But behind that, we already had in mind to start working on a C++ API. That's work in progress. It will be delivered within a few weeks now. And behind that idea, and this will be explained in a couple of slides, it's also to convert that C++ API into a Python API with an interface generator. So that was 2025. This is when things get a bit emotional. I'm going to have to say goodbye to all of you. I've decided to take another opportunity in my career, sort of going back to where I come from, which is material forming simulation. I've spent 10 wonderful years, almost 11 wonderful years, within Citron and Texas 3D with wonderful people, wonderful teams, growing wonderful products, and really happy to see that the succession is completely ensured, and I'll let Jonathan introduce you to our new team. Thank you.
Thanks, Andreas. It's bittersweet, isn't it? But you're not going far. You're going down the road.
It is emotional. Yeah. No.
Going down the road to our partner Transvalor and
exactly. I'm going to be a partner, so watch out.
Yeah, so we'll still see you at NAFEMS, but we have a great team taking the lead now with the departure of Andreas. So I'd like to introduce Alexandra Christoph, who's going to be the new product manager and owner. So you'll get to know her, and she's going to talk about where we're going this year. And she'll be supported by Victor, who's been part of our team for quite some time now as the engineering manager. So not quite as new of a face, but we're making sure that we continue to support these exciting products. So Alexandra, why don't you tell us where we're headed this year?
Yes, thank you, Jonathan, for introducing me. And I'm just looking forward to working with all of you with the CAE toolkits. So I'm going to talk about what is coming for 2026 on Access side. So as Andres said, we are currently working on the C++ API, and after that we will go to the Python API. So why we have decided to do that, a little bit of context around that. We have seen a lot of partners doing great stuff, powerful work, and working with AI ML as well. And we hope to help them by providing a new Python API. So basically here, we want just to provide an interface. Everything will be the same behind the interface. So basically, if you know the Access toolkit right now as it is, and you know Python, it should be familiar for you. So nothing to worry about about this new API. It's to help you to have a better integration if you want to work on a Python model or something like that. And also our goal is to help you to have to improve your practice and to have better practices with the Python tools. And this is going to be the first big project for the beginning of the year. And following that, we will start working on the multi-threading for the reading of CAE data. So why we have decided to work on that? So far, it was single thread. It was not really always optimal for the way to access the data, especially with larger data set and with tighter performances. So it was not always easy to reach a very good performance. The memory was sometimes a little bit short. So we have decided to help you and to add a feature. We want to add a multi-threading support inside of the toolkit. And yes, so basically the core idea here will be to be able to perform multiple queries with several threads on the same in-memory model. So what we expect with that, we expect to have better performance for you. Also, we want to have, you should be able to choose if you want to have something parallel or not when you use the toolkit. Also, this is something we had in the toolkit. This is not something we are going to impose to you. So basically, it's going to be, everything will continue to work as it is and behave as it is today. So nothing to worry about that. Our goal is to help you to have something already included in the toolkit to reach better performances. And yeah, next slide, Jonathan, please. Thank you. So what is coming on Envision side? So we have the particle-based simulation visualization. So a little bit around that. So the particle-based simulation are becoming increasingly popular right now. And it has moved recently from a niche to a very high topic because of the GPU acceleration. Some of the reason was the GPU acceleration. So what we want to do here is we want to be able to support the visualization and the post-processing for larger model. And what we want to visualize exactly, we want to be able to visualize the flow and particles attributes. You should have access to scalar and vector results. And something to keep in mind as well for Envision. So it's going to be non-intrusive. It means it's read-only in this case. So you will just provide the data and you'll be able to visualize and display the result you will send. And it's a low friction as well. No need to rerun any computation in this case. It's purely visualization. So what the benefit we can have with this new model is to now you can see where and why something goes wrong. You can follow the particles, you can follow the flow. And this is another way to have a visualization on a new solver. Something else coming for Envision, we are working already on it. It's a server-side rendering. So for now, what was included in the Envision, it was the client-side rendering. It's great for most of the case, for most of the models you are using, but sometimes with extra large model, it can be an issue. You can have the fluidity can be a little bit poor, or it can be time consuming. The first load can be a little bit can be slow as well. So to avoid this kind of issue, the server-side rendering can be the option and can be the solution in this case. So basically what is going to happen, everything will be done on the server side. The server will resolve the data, the server will prepare the view and the server will send after that the view to display on your side. So what we expect with that as well is to be able to display pixel streamings, we want to be able to display extra large models. And basically, it's not something, it won't change what you're doing right now. Once again, if you want to continue to use client-side rendering, you can do it. But server-side will be available if you need it. If you don't have any other options, you can switch and use the server-side rendering to optimize your rendering. And yeah, just one thing to keep in mind for the server-side rendering, it's not like a feature, it's more an architectural improvement on our side. And yes, next slide. Thank you, Jonathan. Something coming for Envision as well. So far, the product line of the line of the CA product was to we solve and we have access to a lot of data coming from the FEA world. And what we want to do with Envision now is to be able to visualize and display all the data we have on the access with the access product. Sorry. So basically, right now we have some data structure missing or some element are missing, and we want to be sure we cover everything now. And with Envision, you can visualize everything you can access with interoperability, with our interoperability toolkit. Next slide, please, Jonathan. Something a little bit different is coming this year as well. So we are right now working on a bridge between the CAD and the CAE worlds. So basically, we will have a bridge between OOPS Exchange, Polygonica, and OOPS Mesh. So a few words just to give you just a quick example how it will work. So we will import some geometry and typology with OOPS Exchange on the CAD side. From the CAD geometry and the CAD typology, we will be able to, with Polygonica, to fix some issues with the geometry and the tessellations. And after that, everything should be clean and ready to use our OOPS Mesh toolkit. So to keep in mind, the OOPS Mesh toolkit will be able, from this bridge, we will be able to mesh 2D and 3D geometries, and very complex geometry in this case, properly. And next slide, Jonathan, please. So let's have a quick look at the roadmap for SAM first. So what is coming this year? So I've already presented a few of these features previously. So what next? I can mention here. So we are working on delivering SAM as a standard binary distribution. So it is a part of our alignment with the other toolkit provided by Techsoft 3D, and it's also a way for us to simplify your experience with the toolkit. What else is coming? We have an OOPS Access demo viewer. So the main goal of this viewer will be to have something. We want to develop a new application with Envision to be able to visualize everything Access can share with you. I mean, everything that we can have access with our OOPS Access toolkit. So it is a way to check. We hope with this new application, you will be able to quickly visualize what's inside of your CAE Forma model. And also we will update our current already supported formats, and we will work on the new Fluent HD5 format as well. Next slide, please, Jonathan. Thank you. And so what about the Envision side, the roadmap? So I've already presented the particle-based and server-side rendering. We are going to work on the full FEA coverage. So this one has been presented as well. We are going to work, it's going to be a part of the FEA coverage as well, to use of CAD surfaces. So basically with this one, we want to be able to select a boundary mesh element with a CAD surfaces. So it's going to be a part of the bridge with the CAD. And we will update as well our demo application. So far it was a little bit old, so we want to update it, and to ensure it will be now update every time we have a new release to give you the access to the new features. And the support of all data provided by OOPS Access will be a part of the rest of the uniformization of our products. And yeah, that's it for me. Thank you, Jonathan.
Yeah, excellent. Thank you, Alexandra. And thank you, everyone. We do have a couple questions that seems like we're already answered, but just for everybody, will there be USD support and access? That'll be actually through Hoops Exchange, so we can talk to you about providing that through that SDK. And then a good question, is there a method to identify components of an assembly that remain unchanged or have changed between revisions? So I believe you're talking about particularly CAD data as you're editing the CAD data. And so there are some methods within Hoops Exchange that allow you to do that, particularly with unique IDs. However, it's not for all file formats. We have some documentation on persistent IDs there. One question, Andreas or Alexandra, has come in. How useful will visualizing pre-processed data be in Hoops Envision?
Well, that's something that sparked more or less the whole idea, as far as I understand, and I'm haven't at least dug into it too much, but all the AI ML workflows are very eager to get their hands on the full data set, including pre-processing. And as you know, data has to be cleaned up, and you need to be able to look at that data. So at least for that, and I guess for any traditional old-time CAE workflow application that is built around a solver, it's quite cool to have a one visualization tool that handles the full workflow.
Okay. Okay, great. And then looks like one last question here. When will the solve, access, and mesh binary distribution become available? Binary distribution. And will you keep using the current obfuscated code one?
Want me to take that, Alexandra? I don't want to step on your toes too much.
We can go.
Okay. Well, no, we will continue providing the obfuscated source code distribution for our partners. Obviously, we aren't going to force them into reviewing all their build system and their integration. However, I have had talks with some of them who will be happy to skip that build step and remove some complexity in the integration of our API. But yeah, the legacy, software never dies, and legacy will always be there, basically.
Great. Great. Well, thank you. Just in closing, thank you everyone for joining us today virtually. We'd love to connect with you in person. So we'll be at a number of events in the very near future, talking a lot about Hoops AI. So a very exciting new product here, particularly if you are in the Boston area or northeast of the US, we will have a partner day at the Topgolf Boston location where we'll have a technical demonstration and talk about where Hoops AI is going as well, kind of digging a little bit deeper. We'll be joined by our CTO, Gavin Bridgman there, and then an opportunity to network with other independent software vendors in your area using Hoops technology, and just in 3D engineering. So they actually might not be using Hoops technology, but a real great opportunity. So if you're in the northeast of the US, we'd love to see you there. If you're in Europe, we have a number of different conferences we're attending and presenting at, including the PLM Components Innovation Conference hosted by Siemens. We know we have a lot of people in the Siemens ecosystem as well. So we'd love to meet you in person. If you saw something today that interests you, we'd love to talk to you more about our technology and how it can help solve your needs. So please reach out and contact us. We have 60-day evaluations of all of our SDKs that you can sign up for and use, full feature sets of our applications for data access, simulation and modeling, and visualization. So we'd love to be able to work with you if we aren't already, or if you're using one of our tools. They work well as part of a portfolio, and you can really gain the strength of all of that. But it looks like we don't have any more questions. So thank you for joining us. We look forward to seeing you in real life or back here next year for our product update or somewhere else in the virtual space. So thank you, everyone. Thank you for our wonderful product team here for putting this together, as well as our engineering team for all that they have built in the last year and where we're going as well. And of course, thank you to all of you, our partners, because these partnerships really allow us to build this innovative software and support you. And it's really exciting to see what you will be doing in the coming year. So take care, everyone. That's it for now. Please fill out that survey once you exit the webinar. We'd love to hear more about what your needs are or how we can support you. So please remember to do that. And we look forward to seeing you soon. Thanks, everyone.